Hello and what's up guys, Medium Guy here. Welcome to the next video in the Caddy playlist. So in this video we're going to learn and deep dive more into bot detection, and we'll actually try to allow some bots on some defined paths and also deny some defined bots on some other paths. So if you haven't watched the previous video where we actually learned about the basics, the installation and basic configurations and stuff like that, you can actually find the link to the whole playlist down in the description section. So if you want, you can actually go back and watch the previous video and then come back. So you'll be having a general overview of what we're actually doing in this video. So without any delay, let's get down to work. So actually, as you can see in this picture, we've got our backend services that is served on a local network and are actually interfaced with a reverse proxy, which in this case is Caddy itself. So as a result, all the requests from all the clients, including the human clients and the bot clients, will be passed through this reverse proxy and then will or will not be received by the backend services. So what do I mean when I say will not? Is actually some configurations that we define on the Caddy level. So Caddy will check if some conditions are true. It will actually drop the request and send some static failed responses back to the client. So like for example, you have some resources or some backend services that you don't want to actually be crawlable or accessible by some bots, or totally differently, you have some backend services or front-end services or whatever that is actually proxied behind this Caddy server to be only accessible by some bots that you trust, and you actually want to allow crawling your website, getting some information, like for example Google bots, in order for your application's SEO or any other use cases that you might want to integrate your application with. So this is the basic of the total configuration that we want to configure Caddy to be functioning as we desire. So I'll try to move to the terminal. I'll hit ls. You can see all my configuration files that I'll put in my GitHub repository, and you can find the relevant link down in the description section of this video. So as you can see, I've got a Docker Compose file. If I nano the Docker Compose file, you can see that I've got two services. One is a dummy echo server acting as our backend server, and the other is the Caddy server itself. So I'm using a very recent version of the official Caddy image. I've set the restart policy to define to the Docker engine to try to actually recreate and restart this container if by any reason it gets destroyed or stopped. So I've passed the time zone environment variable in order to set the time zone inside the container that will be created. And next over here I've got the ports section that I'm actually mapping my desired ports to inside the container that will be created, and the Caddy server listening inside that container on these two ports will be actually accessible from the outside network of that container. So as a result, I as a client will be able to make requests that will finally be received by the Caddy server inside the container. So the last thing over here, I've got the volume section. So I'm mapping the ./caddy file, which will hold all the configuration and my desired state of the Caddy. So it'll be mapped to the /etc caddy/caddy file, and it is actually the default file for the Caddy to be trying to configure itself as it comes up. So I've got the ./data and ./config mapped to /data and /config inside the Caddy container. So these two directories are the directories that the Caddy server will actually try to store its data and configurations that it will try to create. So I'll try to exit from the nano, and if I go to the Caddy file itself, you can see that I've got some basic configurations. On the global section of the configuration, I'm setting the auto redirect of the HTTP to HTTPS to off. so I'll be able to also make requests to the HTTP port. So right over here, you can see that I'm telling the Caddy to listen on ports 80 and 443, and inside this block I'm actually trying to define the user agent headers that later I'll be using to allow or deny the bots based on these headers. So as you know, for telling the requests that are being sent by bots, we can actually check the user agent header of the request, and by the value of the user agent header of the request, we can then decide if the request is sent by a human, a browser, or a bot, and then also we can actually tell which bot it actually is. Like for example, we can have bots that are using the curl as their client to make requests. So as a result, we can actually allow or block the requests that has the curl keyword in their user agent header. So as a result, we'll be able to block or allow that exact robot. So I've got another block for the forbidden headers. So actually I'll be using one of these two blocks in order to tell the Caddy to decide to proxy the request to the backend server or not. So next, right over here, you can see that I've got a reverse proxy directive that I'm passing the allowed bots, and then I'm actually proxying the request to the backend on port 80. So backend right over here stands for exact same service that we created in the Docker Compose file for the Echo server. So because these two containers will be created on the same Docker network, they will be actually able to call each other through their Docker Compose service names. So as the last directive, I'm using the respond, and I'm passing the forbidden matcher in order to respond with the 403 status to the requests with those exact headers. So right now, the thing that I expect is for the clients that has curl or Mozilla in their user agents to be able to successfully make requests to my backend server, and if their relevant header does not include these two keywords, their requests will actually be dropped on Caddy level and won't actually be proxied to the backend server itself. So I'll exit the nano, and if I say docker compose op-d, as a result, I can see that my both containers have been created successfully with a network attaching these two containers to that network. So if I say docker compose ps, I can make sure that both my containers are up. Also by saying docker compose logs -f to follow the logs, and --tail 100 in order to grab the latest 100 lines of the output of these two containers. So as I can see, things are looking correct, and if I move to another terminal and by using the curl command, I'll try to make a request to the address of the machine that is running the Caddy container. So if I hit enter, you can see that the stats code for the request is 200, which is okay, and I am able to receive the response from the backend server that is proxied behind the Caddy server. So like for example, if I use the wget in order to make requests to this exact address, if I hit enter, you can see that I'm getting 403 from the exact same address that is both handled by the Caddy server. So because the wget is not in the allowed list of the user agent header in the Caddy file, the bots using the wget to make requests will be blocked and won't be able to crawl your application. So wget is just an example tool to showcase this scenario. You can actually get the idea and try to allow or block your desired bots to your application using this exact same configuration and this exact same Caddy file. So what if we want to reverse this exact configuration? So like for example, we've got a backend service that we actually don't want some exact bots, some exact user agents to be able to make requests, but all the other bots, all the other user agents to be actually able to make requests. So actually we can go back to the Caddy file. So I'll hit Ctrl+C to exit out of the logs. I'll hit ls and try to again nano the Caddy file, and right over here I'll try to reverse these two matchers. So instead of saying allowed bots in the reverse proxy directive, I'll pass the forbidden matcher, and for all the other requests I'll pass the allowed bots matcher. So I'll hit save and exit the nano and try to say docker compose down and docker compose up -d. So this will actually try to remove the existing containers that have been created by this docker compose file and recreate those two containers. So by doing this, the Caddy file will also be renewed inside that container, and the Caddy server will be trying to configure itself by the new configurations. So again, I'll hit the logs to make sure things are working correctly. And again, if I move to the other terminal right over here, so right now if I try to make requests using curl, I am actually expecting to receive 403. So I'll hit enter, and you can see that the stats code for my request is 403, and I get the access denied as the response for my request. So again, I'll try to use the wget to make requests. I'll hit enter, and you can see that the connection has successfully made to the Caddy server with the status 200, which is okay. So the thing that we just did using this configuration is that we actually denied some exact user agent headers, some exact bots, but we actually allowed for all the other bots and all the other user agents to be proxied to our backend services. So that's all for this video. I hope you learned something new in this one. So actually by using these two methods, you can actually detect the bots, and based on your use cases, you can actually allow or deny or create your custom configuration to actually allow the requests to be proxied to the backend services or not. So if you have any questions, any recommendations, of course go ahead and ask me in the comment section down below. If you found the video useful, please don't forget to like and subscribe, which will help grow the channel and motivate me to create more free contents like this. And lastly, don't forget to watch the other videos in this video series in order to dive deeper in the Caddy and all the cool features that we can implement using the Caddy as our reverse proxy to our backend services. So with that, that's all for this video, and I hope to see you in the next videos.